Today I'm going to show you how to locate the image for a reflection in a curved mirror by using a technique called ray tracing. Now, in order to use ray tracing, there are basically 3 rules that you're going to have to remember, and we'll go through those as I do each drawing. I'm going to do 2 examples for you. As you are doing these in your assignment, I would highly recommend that you use a compass to get your mirror the right size of the right curvature, and you're most certainly going to need a ruler. I think everything that he gives you is in centimeters, so hopefully that won't cause any types of problems for you as far as finding something that will allow you to measure in centimeters. If you are in the United States, or if you have gotten your compass here in the United States, it is possible. I've actually not bought a compass anytime real recently, but I know all the compasses that I have here actually have their markings in inches. Even if that's true for you, if your compass doesn't happen to have markings on it in centimeters, you can still take your compass and put the 2 ends of it on a centimeter ruler to make sure that you are actually measuring the correct radius on it. So I have pre-measured these to save us a little bit of time as we're going through this. So example 12.1 says an object is placed 20 centimeters from a concave spherical mirror that has a 10 centimeter radius of curvature. How will the object appear in the mirror? So what that means is that if your mirror has a 10 centimeter radius of curvature, that means that the point of your compass is here, and from here to the end of the pencil is 10 centimeters. So that's where you're going to draw your arc. So this is where the radius is. If this is at 10 centimeters, then your focal point is going to be where? Well, if you remember, the focal point is half of the radius of curvature. And so if the radius is at 10, the focal point is going to be at 5 centimeters. Okay? It told us that the object was located at 20 centimeters. And so the object, a lot of times what we do is we use an upright arrow to indicate the object. An arrow is something that's very simple to draw, and we can certainly tell one end from the other. Okay, so that's how we're going to get the drawing set up, and there are 3 specific kinds of lines that we're going to draw to determine where the image is. When I do this, I'm going to use 3 different colors so that you're able to see where all of your lines are going. Some students will find it helpful to use colored pencils so that they can see each individual line as they're going through it. I'm not requiring that, but I do want to let you know that you may very well find that to be helpful. Okay, so as we've already talked about, we know that any type of horizontal light ray that's going into the mirror is going to be reflected back through the focal point. So if I draw this first horizontal light ray going in here, if I draw a horizontal light ray, oops, I need to scoot that up a little bit more, coming off the top of my object and going into the mirror like this, okay, then what's going to happen is that when it reflects off, it is going to reflect through the focal point. So I'm going to take the point where it hit the mirror, and then I'm going to draw it, whoops, right back through the focal point like that. Okay? So there is the first light ray. The second light ray that we can draw is one that's actually going to go through the focal point, because if it goes through the focal point, it's going to reflect off horizontal. So it's just kind of the opposite idea of the one we already drew. So if I reflect it from the top of the arrow through the focal point like this, then when I reflect it back through, it's going to reflect off horizontally. And so that light ray will reflect back like this. Okay? May have to get a little bit darker pen for that next one. That one's a little bit hard to see. Okay? Let me just go over it here, see if I can make it darker for you. It's not quite as straight, but hopefully you can see it a little bit better. Okay, so there's the blue one. The third light ray that we're going to draw is going to come from the object, and it goes through the center of curvature, and when it goes through the center of curvature, it bounces right back along the same path again. So if it comes in through the radius of curvature from the top of the object, so it's going to come like this, and it's going to come down like this, and then when it reflects back, it's going to reflect back along the same path. Okay, so you can see my three different colors there. And so therefore what that means is that where these three light rays cross is where the image is formed. And so all three light rays cross at approximately this point right here. So I'm actually going to draw this with a dotted line so that you can tell the difference between the object and the image. And you can tell, since the light rays originated from here, the tip of the arrow is going to be where they cross. Now, since we know that a light ray that goes through the radius is going to bounce back along the same point, any light ray that's illuminating the bottom of this arrow and bouncing back along the same point, that's going to be where the bottom of the image is as well. Okay? So, therefore, this image is actually formed by an intersection of light rays. It's not like in the plane mirror and the flat mirror that we already looked at, where I had to extrapolate the light rays backwards. Instead, these light rays actually cross and intersect each other. And so in place of a virtual image, this image is actually a real image. So a real image is formed when your light rays actually intersect one another. And then there's two other characteristics that we're always going to use to classify an image. Compared to the way the object was, the image is upside down. And so we say that this image is inverted as opposed to being upright. So it's a real image, it's inverted from where it was before, or it's upside down. And you can also tell that based on the size that this one was, this image is much smaller than it was before. So the image is real, it is inverted, and it is reduced in size. Okay? So there's our first example of a ray tracing diagram with a concave mirror. We will do another example, which is example 12.2 in your book. And example 12.2 says an object is placed 5 centimeters away from a concave spherical mirror that has a 14 centimeter radius of curvature. And we're supposed to draw a ray tracing diagram for this one. So here, I pre-measured this already, so don't think I'm just pulling this, just off the top of my head someplace. This right here is the radius of curvature, so this one is going to be at 14 centimeters. Where does that mean the focal point is? Focal point's going to be at 7 centimeters, so my focal point is right here at 7. And then it said that the image is located at 5 centimeters. So my image is located right there. Okay? So we're going to basically follow the same rules here that we did before. So we're going to start out with a parallel ray. And just like we did before, we know that if a ray goes in parallel, it's going to reflect back through the focal point. So if I draw this ray in going parallel, it's going to reflect back through the focal point, which is going to be like this. Okay, so there's our first ray. The second ray, we said if it goes through the focal point, it's going to reflect back off parallel. And that blue marker didn't work so well that last time, so let's try the green one this time. This object is in front of the focal point. So what I need to do is I have to draw it up this direction So if it originated from the focal point and caught the top part of the object, that's how I'm going to draw that ray. So this one's going to come in like this, and then when it reflects off, it's going to reflect off parallel. Let's see if I can get that straight there. It will reflect off like this. Okay? And then the third line, we had said that if it goes through the center of curvature, it's going to reflect right back through the center of curvature. So if my center of curvature is here and it goes back through the radius and I take it in like this, it's going to reflect back right along that same line again. Okay, well, now I have an interesting predicament because up here, all three of those reflected rays crossed. Down here, I got one there, I got one there, and I got one there, and they didn't cross at all. Well, what kind of image does that form? Well, it's not going to form a real image because what I have to do in this case is I actually have to extrapolate these lines backwards now. So what that means is that this image is going to be formed in place in front of the mirror. It's going to be formed back behind the mirror. So I'm going to take this axis that I have and I'm going to have to extend it back this direction so that I can tell where the bottom of my image is going to be located. So if I take this ray that went in parallel and went back to the focal point, and if I extrapolate it backwards like this, extrapolate that one backwards, I may have to go a little bit further with that one, like this. Then the one that went through the focal point and reflected off parallel, I'm going to take that reflected beam and I'm going to extrapolate that one backwards like this. Okay. And it looks like I still quite didn't get that line extended quite far enough, so I'm going to have to go a little bit further there so that they actually cross. And then if I take this reflected beam and I extrapolate that one backwards, I think you can see there what's going to happen. And extrapolate this one backwards. Okay. And obviously it didn't quite end up exactly the way it was. Sometimes your drawings don't end up great, and because I'm doing this on a dry erase board, it makes it a little bit more difficult sometimes to get all my lines exactly where they're supposed to be. But you can tell that these lines are going to cross back here behind the mirror, and so my image is going to be located all the way back here. Now, in this particular case, as I said, we had to extrapolate these light beams backwards in order to see where they were going to cross. So since I had to extrapolate them, I now have a virtual image in place of a real image. So again, the difference between a real image and a virtual image, in a real image, your reflected light rays actually go back and cross at a particular location. In a virtual image, you have to take the reflected light beams and extrapolate them backwards back behind the mirror to see where the image is going to be formed. In this case, up here, this image was flipped upside down, but now this image is actually the same direction as the original one was, so this is an upright image as opposed to being inverted, and you can tell that this image is much larger than the one I started with, so in place of being reduced, this image is magnified. Now, both of these are concave mirrors, so what you can see is that it depends where, and it all has to do with where in relation to the focal point and the center of curvature your object is located. I think I actually put this on tomorrow's lesson plan, but you're going to be filling out a chart where you're going to be trying to figure out, okay, what is the relationship between where I put my object and what kind of image is going to be formed when I do that. I think that's probably not going to be until tomorrow's assignment. So today I just want you to focus on trying to figure out exactly how to get these rays drawn so that you are able to figure out what kind of image is formed with that.